Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is find minimum in rotated sorted array. So it's a medium level question and it's a very popular question. So let's read the problem statement. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. So we are given with an original sorted array, and if it is rotated between 1 and n times. So if it is rotated 4 times, this is the resultant array, and 7 times, then it comes back to the original array. So if you what is the rotating means? The rotating means the shifting the elements one position right, if we are rotating one time, right, clockwise direction rotation. So if I say rotating an array, and this is the array one time, it will result in the array this. So what is happening? A0 is replacing A1, A1 is replacing A2, and so on, and the last element comes at the first position, right? So this is the rotation means, and all the elements in the array are unique. So we have to write an algorithm that runs in log n time. So the simple way is to find a minimum is comparing each element, right, in the for loop. So that's big O of n. So whenever searching in an array using with an log n time complexity, what comes into mind is binary search. But for binary search, the element should be sorted, right? Elements should be sorted, but here the sorting nature is removed because the array is rotated. So rotation has removed the sorted nature. So what we have to do is we have to optimize our binary search. So let's see some conditions or some possibilities on the basis of which we can raise our optimized binary search. So if you see, if the original array is same as it is, right, it's not sorted, like the first minimum is at the first position and maximum at the last position, so it is not sorted. So we'll return nums of 0, because this will be the minimum element. But if this is not the case, then the array is sorted either one time, two times, three times, we don't know. Or so suppose, so what is the second possibility? What is the second possibility? This is first possibility. What is the second possibility? If the element is rotated, like suppose in 1 2 3 three times, here it's rotated 3 times, so the middle element is greater than nums mid plus 1, right? Nums of mid is greater than mid plus 1. This is the middle element highlighted by red. So red elements are middle elements. And how do we find middle element? Middle element is left plus right, right, divided by 2, middle element. So here you can see, after 1 2 3 rotations, the middle element 6 is greater than nums at mid plus 1. Mid plus 1 is this, and this is middle element. So middle element is greater than mid plus 1, so we will return, we can say that the middle element is nums of mid plus 1. Now what is the third possibility? Third possibility is if the middle element is smaller than mid minus 1. This is middle element and this is mid minus 1. So if you say, if I've rotated 2 times, this is the resultant array, and the middle element is smaller than the mid minus 1, so we can say that the smallest element is nums of mid. Now if these three conditions are not met, then what we will do, we have to go on the right or the left part. If we know our binary search, what happens in binary search, there is a mid element, and if the element is not equal to mid, either we go on the left or on the right. Similarly, so what can happen, that the middle element can be greater than the nums of 0, right? If the nums of mid is greater than nums of 0, right? So in that case the smallest will be on the right part of the mid. Smallest is on right of mid, and we have to change mid is equal to low plus high divided by 2. So this was our low, this was our high, L high, right? And this was our mid. Now the nums of mid is greater than 0, right? If the three conditions are not met and we check that mid is greater than nums of 0, so the smallest will be on the right part, smallest will be so we have to move our left from here to mid plus 1. So here left will be equal to mid plus 1. So this will be our new left, this will be our left 6, right? And again the same process will go on. We'll compare the second and third, we'll compare the second and third. Now if so this is on the left side. So suppose the middle element nums of mid is smaller than nums of 0. In this case the 2 is smaller than 6, right? So the middle element will be on the left, middle element will be on left. So for this middle element is on left, right? So again if the middle element is on left, so and this is low, this is high, and this is mid, what happens? High equal to mid minus 1. So 1 will be our new high, right? So this is the way we will optimize our binary search. Let's see one example. We are given with a rotated array. It's a rotated array, rotated array. So we'll define our left and this is our right. So mid will be, mid is equal to, so this is 0 1 2 3 4 5, this is index. So mid will be 0 plus 5 by 2, that is 2. So this will be our mid. Now the first we have to compare if nums of 0 is smaller than nums of right. No. So we can say it's not sorted, it's rotated. Now the second point, that nums of mid is greater than nums of mid plus 1. No, right? So we cannot say nums of mid plus 1, that we cannot say. Now third condition, if nums of mid is smaller than nums of mid minus 1, this condition is also not met. So now we have to divide out we have to see in the left or the right part from the mid. So what we check is nums of mid, it's greater than or smaller than, so it's smaller than nums of 0, right? So smallest element will be on the left side. So what we will do, our right will be equal to mid minus 1, right? So left was 0, so it will remain 0, and right will become 2 minus 1, that is 1. Now again we'll calculate the mid, again we'll calculate the mid part, right? Again we'll calculate the mid part. So mid is 0 plus 1 by 2, that is 0. Now again we'll check from here, not this one. This is only one time, this is only one time, because it is a check that tells whether the elements are rotated or not, so it's not the part of the binary search. Now for the second time, as we have moved on the left side, middle element is 0, so we'll check nums of mid is greater than nums of mid plus 1. So yes, nums of mid is 6 is greater than mid plus 1, that is 1. So we'll return nums of mid plus 1, that is 1. So 1 is our smallest element. And let's see the code part of it. So here we have initialized n equal to nums dot length and n equal to 1. If n equal to 1, then return num 0, because there is only one element, so that will be the minimum. We initialize our left and right, 0 as n minus 1, 0th element, 0th index, and the n minus 1th index. If nums of right is greater than nums of 0, it means it's already sorted. We have to return the nums of 0. Otherwise we'll do the binary search and we'll have we'll do our binary search and we'll go with till left is smaller than equal to right. With the usual binary search, we calculate our middle element. If the nums of mid is greater than nums of mid plus 1, the first condition, what we return? We return nums of mid plus 1. So we'll return nums of mid plus 1. If nums of mid is smaller than mid minus 1, second condition, what we return is nums of mid. The middle element will be the smallest element. Otherwise, we have to decide to go on the left or the right, depending upon nums of mid is greater than nums of 0 or smaller. If it is greater than 0, we'll go on the right part, because the smallest element will be on the right part. Else, if nums of mid is smaller than nums of 0, we'll go on the left part, because the smallest will be on the left side. And we'll shift our left as mid plus 1 and right as mid minus 1 respectively. If there is no element found, the minimum element, then we return integer dot max value. So let's run this program. So yeah, it's running fine. So I hope you like this video. If you like this video, please share and subscribe. Thanks for watching.